All right, in 7.7 part 1, we are going to look at the polar form of complex numbers. So if you remember, way back in algebra, a complex number is just a number that has a real and an imaginary part, right? Generally written in the a plus bi form. Okay, so here we have two examples of imaginary numbers, 1 plus 3i and negative 5 minus 7i. So we can plot them in the complex plane, right? If we say that this axis is the real axis and this axis is the imaginary axis, so plotting plotting these numbers would be very similar to plotting the point 1, 3, right? So I would say that the real portion of this first number is 1. The imaginary portion is 3. Oop, that's a little bit off. Okay, so right about there at 1, 3. Now, magnitude is going to be very, very similar to finding the r value that we did in the last section, finding polar coordinates. So the magnitude is just going to be very similar to the absolute value of a number. It's just the distance from 0. Okay, so if I say the absolute value of 1 plus 3i, okay, that's the distance from the origin, right, or the distance from the number 0 plus 0i. So all I would do here is take the square root of 1 squared plus 3 squared. That'll get me the distance here. So that'll be 1 plus 9 is 10, the square root of 10. Okay, and that is the most simplified version of that radical, so I can leave that as just the square root of 10. For this one, right, to first plot this, I would say negative 1, 2, 3, 4, 5, and then down 1, 2, 3, 4, 5, 6, 7. Get me right about there. And then the absolute value of that number is very similar to the magnitude. Right? All I'm doing is taking the square root of a squared plus b squared. So that'll be the square root of 25 plus 49, which would be the square root of 74. All right. So that is the absolute value of a complex number. All right. So now let's apply this or take this idea into polar form. Okay. So the complex number a plus bi can be written in polar form as z equals r times the cosine of theta plus I times the sine of theta. And then we have all these conversion factors here. A, in our rectangular form of the complex number, is just equal to r times the cosine of theta. B, which is the imaginary portion of the complex number, is equal to r times the sine of theta. R is a squared, the square root of a squared plus b squared, and tangent of theta is b over a. Right? So if I want to convert a complex number in rectangular form into polar form, there are two things that I need to do. I need to find r, and I need to find theta. So to find r, we are just taking the square root of a squared plus b squared. So in this case, that'll be the square root of 2 squared plus negative 2 squared. So square root of 4 plus 4, the square root of 8. We can simplify that, right? We could simplify that into the square root of 4 times the square root of 2, which would just be 2 radical 2. So that is my R value here. Now, to find theta, what we really want to think about is finding our reference angle, okay, and then determining the actual angle based on the reference angle, much like we did in the last section. So to find the reference angle, which we're denoting with this little prime here, we're just going to take the inverse tangent of the absolute value of b over a. So in this case, that would be negative 2 over 2, right? B over a, because this is in the form of a plus bi. So since we're taking the absolute value, this would just become the inverse tangent of, so this would reduce to -1, but the absolute value of that would be +1. So inverse tangent of +1, we can put that in the calculator, or we can think about where on the unit circle does tangent equal 1. Well, that occurs at an angle of pi over 4, because square root of 2 over 2 over square root of 2 over 2 would be 1. So our angle, we want it in degrees here. So I would say this occurs at a 45-degree angle. Now, this is the reference angle, so we need to think about where this point is on the graph, right? If I just kind of think about sketching this out, 2, -2i is going to be in quadrant 4. What that means is this angle right here, the angle from the x-axis, is the 45-degree angle. So to get this angle, right, in this case, what I would need to do is take 360 minus 45. Okay, whenever we're in the fourth quadrant, I would take 360 minus the reference angle to get the angle in question. So here, since the reference angle is 45, my theta, 360 minus 45, will be 315 degrees. So now, putting this information together, okay, my final answer, converting this rectangular complex number into polar, would be z equals r, and we found r to be 2 radical 2 times cosine of 315 degrees plus I times the sine of 315 degrees. Okay, so this is the polar form of this complex number. Okay, so we need to first find r. That's just the square root of a squared plus b squared. Find the reference angle, which is the inverse tangent of the absolute value of b over a. And then use that reference angle along with whatever quadrant we're in to find the actual angle measure. Okay? So now let's look at going in the other direction. Let's say that I'm given my complex number and I want to convert that into rectangular form. Well, this process is actually going to be a little bit easier. We are just going to essentially simplify this. Now, this time we are given our angles in radians. Okay, so all I'm going to do is go to my unit circle and see what these exact values are. The cosine of 5 pi over 3 and the sine of 5 pi over 3. So 5 pi over 3 is right here. The cosine is the x value, that's 1/2. The sine is negative square root of 3 over 2. So this is just going to become 4 times 1/2 plus I times the square root of 3 over 2. And then I can distribute this 4. So 4 times 1/2 would be 2. And 4 times the square root of 3 over 2 would be 2 times the square root of 3. So this would just become I times 2 radical 3. Okay, and that's all we need to do. All right? I just need to find these values on the unit circle and simplify. So it is a little bit easier going from complex to rectangular form. All right. So on the back then, let's take a look at multiplying and dividing uh, complex numbers in polar form. Okay, so these are our formulas. Okay, if we have our first complex number in polar form and our second complex number in polar form, to multiply them together, I would multiply the two r values together, but then I'm going to add the angle measures. Okay, so I'm going to take the cosine of theta 1 plus theta 2 and the sine of theta 1 plus theta 2. If I am dividing these two complex numbers, I'm going to divide my two r values on the outside, but then I'm going to subtract the angles on the inside. Okay, and we do have to specify that z2, okay, whatever our denominator is, can't be 0, because then that would lead to not a real number, okay, or not a number at all. So let's try a couple examples here. Okay, let's say that this is my first complex number in polar form. This is my second one. I want to multiply them together. Okay, so I'm going to say that this is going to be equal to, so I'm going to multiply my two r values together. So 9 times 2. And then on the inside, I'm going to add the angles. So this will be cosine of 75 plus 15 plus I times the sine of 75 plus 15. All right, and then I just want to simplify here. So 9 times 2 is 18, and then this will be the cosine of 90 plus I times the sine of 90. And then it does specify that we want our final answers in rectangular form. Okay, if it said polar form, I would stop here, right? This would be my final answer in polar form. But since it says write your answers in rectangular form, we would want to simplify like we did in that last example. So I can go to my unit circle and find the cosine and the sine of 90. Right? Well, that's right here. Cosine is 0, sine is 1. So this one is going to simplify, just down to 18 times 0 plus I times 1. So 18 times 0 is 0. 18 times I times 1 is just 18i. Right, so z1 times z2 is just 18i. All right, so let's try to divide them. Okay, those same two numbers. So to divide, I'm going to take r1 over r2, so 9 divided by 2, times the cosine, and now I subtract my angles. So 75 minus 15 plus I times the sine of 75 minus 15. And we just simplify. So we can leave this just as an improper fraction. And then that would just be times the cosine of 60 plus I times the sine of 60. And again, we can go to our unit circle and find these values. So at 60 degrees, cosine is 1/2, sine is the square root of 3 over 2. So this would become 9/2 times 1/2 plus I times the square root of 3 over 2, and then multiply this through. So 9 over 2 times 1 over 2 would be 9 over 4. And then 9 over 2 times I times the square root of 3 over 2 would be, I'll put the I out front, be I times 9 radical 3 over 4. So this would be that final answer, and that would be this complex number divided by this complex number. Now, I should mention that we could actually, in both of these examples, I could convert this number to rectangular form first and convert this number to rectangular form first, and then multiply them together, right? Then it would just be something like a plus bi times a plus bi, right? Whatever those a and b values end up being, right? And then I would get 18i, right? Same thing here. If I wanted to divide, I could first convert these into rectangular form, and then I would have, that first complex number divided by that second complex number, okay? And this is what we would end up with, all right? So this is just a different way of multiplying and dividing complex numbers, right? We can convert them into polar form and use this. And a lot of times this method would be shorter than trying to divide like this, all right? So that is it for this video. The final question is going to pop up asking you what questions you have.